This shows a simulation of the photoelectric effect. This is a piece of potassium, and the red dots represent some of the electrons that are in the atoms of potassium that make up the metal. This is a light source, and when we flash the light, we'll send a beam of light toward the metal and see if it has enough energy to knock electrons loose and move over here to the detector where we create electricity using light. So photoelectric, because the photo part tells us we're involving light, and electric is we're going to produce electricity or the flow of electrons with the light. Up here we have some controls to change the wavelength of the light source, and we can go from 700 nanometers, which is low energy, long wavelength red light, all the way up to 100 nanometer waves, where we have much greater energy, in fact so great we can't see that light. And then we can also change the intensity of the light with this slider. So we're going to start with 700 nanometers and flash the light, and notice that none of the electrons moved. So let's go to 600 and flash the light again, and still we don't have the right amount of energy. So now let's move it to 500 and flash the light, and notice now some electrons have hopped out of those potassium atoms and are moving over toward the detector. I'm going to put it back at 700 just so I can show you something. Let's change the intensity. Let's put it all the way up to 100% and flash the light. And notice that no matter how high or how low that intensity is, it doesn't matter. We still can't get the electrons to bounce. So let's put that back to 50. Now, the next thing that I'm going to show you is we can change the kind of metal it is. So let's try calcium, for example. So now we have a different metal, but the same setup. And let's try that red light again. Nothing. Well, 500 worked pretty well for potassium. So let's go down to 500. And let me show you that one. Still nothing. So let's just keep moving. 400. And now we finally get some electrons to move. Now, a minute ago, I went to the very long wavelength, low energy red light. And now we're at pretty high energy light with this blue color. What I'm going to do this time is turn the intensity way down to see if we reduce the intensity of the light, will we be able to move any electrons? And so it turns out once you have found the right wavelength or frequency of light, no matter what you do with the intensity, you can still make the photoelectric effect happen.